Hello everyone. Today we are going to discuss about phasor representation of alternating quantities. It is very important for an electrical engineers. So we have to represent some alternating quantities in a vector diagram, or we have to represent those things in a vector forms or phasor forms. Studying about machines, especially in power electronics subjects. So those at those point of time, you have to represent some mathematical equations or vectors on a plain paper with phasor diagrams. Okay, so for those things, you should learn this phasor representation of AC quantities. So what is this phasor representation? It means that an alternating quantities are represented by phasors. So any alternating quantity can be represented with a phasor. A phasor is a simple line. That length of that line is nothing but a maximum value of that quantity or maximum value of that waveform. And that line will rotate in a anti-clockwise direction on a plane with a velocity of W, or we can take it as a omega. So that is called angular velocity. So if I say here, so if I represent one vector in this way, so it is having some magnitude. So that value will be, suppose it is a voltage waveform, it is a Vm, so maximum value, and it will represent and it will rotate in a anti-clockwise direction with a velocity of omega. This omega is nothing but a angular velocity. Length of this line is nothing but a maximum value, right? A phasor is a line of definite length rotating in a anti-clockwise direction at a constant angular velocity omega. The length of the phasor is equal to maximum value. So this length is equal to the maximum value of the alternating quantity, and the angular velocity is equal to angular velocity of alternating quantity. Okay, so if I represent, suppose, so it is making a zero angle, so this voltage magnitude, so suppose if it is a V is equal to Vm sine omega t. So here it is angular velocity of omega. So if you write omega t plus 0, so 0 is not a specific value, so I can write it is a Vm sine omega t. That means in phase with the horizontal line. So I can represent this Vm sine omega t as this one. So this waveform is nothing but Vm sine omega t. So I can write Vm at an angle 0. So that is the first one. If I want to represent this, V is equal to Vm sine omega t plus pi by 4. So here the phase difference is there. The phase difference is there. The phase difference is nothing but pi by 4, that is 45 degrees. How can I represent this waveform on the phasor represent? How can I represent as a phasor? So here I can write the phasor. The value is maximum value, it will be Vm, and it makes an angle of pi by 4 from the reference. From the reference it will make pi by 4, that is nothing but 45 degrees. So I have to represent this omega t plus pi by 4 as like this. If it is pi by 2, so I have to represent like here, right? So it is Vm So it's making 90 degrees. So if it is omega t plus 3 pi by 2. So if it is a 270 degrees, how can I represent 180? So it is like this. It is Vm, and this will make an angle of 3 pi by 2. So in this way I can represent different waveforms on the vector notation, and this is also known as a phasor representation of a AC quantities. Okay, these are all RMS values. So let's represent these values. I1 is equal to 10 sine omega t plus pi by 4. This is one waveform, and I2 is equal to 8 sine omega t minus pi by 3. So how can we represent this I1 and I2 as a phasor representation? Let's see here. Okay, so I2 is the maximum value is 10, and if I take it is as a reference, if I take it as a reference omega t, sorry, it is reference value, it is I value, current value. So it is 10 value I have to represent 10 omega t plus pi by 4. So with an angle of pi by 4, with an angle of pi by 4, it is having some angle 10 at an angle pi by 4. So here it is Vm at an angle 3 pi by 2 and Vm at an angle pi by 2. So here this magnitude is 10 with an angle pi by 4. And the second value, it is I1. The angle is pi by 4. Now another waveform I have to represent as I2, that is magnitude is 8 only, not 10. So sine omega t minus pi by 2 is a minus value, indicates that it is from clockwise, pi by 3 degrees from clockwise, or it is pi by 3 is 60 degrees, that is 60 means it is 310 degrees clockwise, 310 degrees clockwise, or 60 degrees from anti-clockwise, sorry, 310 degrees from anti-clockwise direction, or 60 degrees from clockwise direction. So it is a magnitude of 8 only. So it is 8 at an angle minus pi by 3. It is at an angle of pi by 3. So it is the representation of, so this is the origin. So in this way we can represent I1 and I2 waveform. So how can I calculate the resultant? How can I calculate the resultant value of I1 and I2? So the resultant value in mathematics, it is we already know how to calculate the resultant value. So we have to write a dot, a parallel with 8 this line, and we have to represent this one. So up to this point we can calculate the resultant value. So for this purpose we can have a mathematical method. One method is analytical method. Analytical method. So in this method we can have some of the quantities related to x-axis we can calculate, and so x components, so some of the x components and some of the y components, so some of the x component and some of the y components to calculate. So coming to the some of the x components, for I1 it is 10 cos pi by 4 plus, for second waveform it is 8 cos pi by 3, so minus pi by 3, it is x components. That sum will be, you can calculate by using calculator. We can have 111.07. Coming to y components, 10 sine pi by 4 plus 8 sine minus pi by 3. So we can calculate as 0.14 value. So if you want to calculate total magnitude of I1 plus I2 as sigma x whole square plus sigma y whole square, that will be, so we can have 11.07 again, 0.7 again. So it is a calculation of magnitude when I1 plus I2. So that resultant, it is 11.07. So what is the phase difference? What is the phase difference? So if you calculate the phase difference, we have formula phase angle is equal to phi is equal to tan inverse of sigma y by sigma x. So from this I can calculate 0.72 degrees. So here 11 at angle 0.72 degrees. Okay, so this is the equivalent representation. So I1 plus I2. If you want to calculate addition of two waveforms like I1 and I1 plus I2, so this is the method we can follow. In mathematics, we have already done in intermediate, right? So I think all of you know about this process. So the value is 11.07 at an angle 0.72. So that means this angle. So this angle is nothing but 0.72 degrees. So that is the phase angle between. So that is the phase angle of a resultant waveform obtained from I1 and I2. Okay. And one more method is there. We can calculate, that is a graphical representation. So graphical representation is this one. This is graphical representation. So this is graphical representation. So in this analytical method, we can calculate resultant of any waveforms. If we have three waveforms, so from those three waveforms, we have to calculate the horizontal components sigma x and vertical component sigma y, and from those two values we can calculate the resultant magnitude and resultant phase, right? So this is the phasor representation of AC quantities. Okay, to familiar with this type of problems, so we have to take another examples from textbooks or whatever sources you have. So practice well so that you can be a masters in this problems, right? I hope you got this concept. If you like it, hit the like button. If you have any queries regarding these concepts, so please make a comment. I will definitely answer those questions. If you feel it is useful, you can share to your friends, and finally subscribe to my channel for more interesting videos, right? Thank you very much. Have a nice day.